Hello out there. Welcome to, just fixing up some of the screens on my monitor. Okay, so today, my topic list, right? Oh, let me grab that. Okay, so here's some of the topics that we're going to cover today. Let me see. I guess I'll put it over Oliver. Oh, is it? Is it 2:30? So right on the dot. Good morning. It's afternoon over here. Good evening. Oh, wow. We have people all over the place. Cool. So today's live stream will continue from the last live stream from the lip sync mini series episode 1, which we talked about mostly from my HDA, the facial deforming HDA, and we're going to continue it right off there. So the last week, I'm just going to bring up the HIP file. This is what we did, minus this thing over here. This little thing I added was just caching out some lip sync animation from using one of my deforming HDA tools, facial deforming HDA tools, to make Oliver mouth move like this. Okay, let it render flag on it first. Give it a couple seconds to cook. Okay, there it is. So this makes him move. Look, he focus on this. What I did was some very, very simple open mouth close animation. Had this hook up, this one parameter hook up to link to the silence channel of the CHOPS. Let me bring that up too. So this thing here. Yeah, so you can see that this number here, it's changing as I drag this timeline over. So 1010 flips in and out, and that's being driven by a CHOPS network that is analyzing an audio file that I'm feeding into it. And all I really did over here was link this parameter, this open close mouth parameter, to that one silence channel, so it would open and close at certain parts of the timeline, and then cache it out. So if I just play this, so we're focusing on this node, it's just a file cache node. So he's opening, closing, just random stuff. I believe this was my speech, the text speech I did for one of the promo videos. I just need this, and I'm gonna bring up another file. Oh, where is it? This is the one we're at. This is... Oh, I think I opened two of the same. Oh, that's why. This music driven, this one. Just give me 1 second. I opened the wrong file. So that file cache, I was bringing over to another HIP file to drive some dance moves. And that was just to demonstrate that you can combine lip sync and 3D animation, like the dance moves, together as a whole workflow. So today we're going to first continue off with what we had from last week, the lip sync episode 1, which was the facial deforming, mostly how to use my HDA and how to make him talk. But what powers the talking? So you need something like, you need an audio file, you need speech, or you need some sort of data inputting into it to tell him when to open his mouth and when to close it. The HDA only makes the mesh open the mouth, so it makes it move. So today we're going to finish up the CHOPS network for like the whole workflow. Then you'll have the whole way of setting it up. So some of the bubblepins members probably got this file from here, from the last week. So last week I created this page where you can download the HIP file from last week, which is the setup you see on my screen right now. And I had a little sticky note saying that we're going to cover this CHOPS network next in the next episode, which is today. So that's what we're going to focus on today. This is getting translating the audio into data, which then plugs in to the facial deforming node network that we set up last week. Let me pull up this. Hello. RBLX. Did you use a reference picture for the mouse shapes? Yes, I did. I googled what did I Google? So I googled phoneme values. And then just look at the image search, and there's like okay, maybe not that. Mouth. Lips. There you go. So you get a bunch of different search results from the lips. Maybe if you take this out, mouth. Maybe if I put lips. Yeah, that's a bit better. Okay, so if you search phoneme lips. So I've been pronouncing it incorrectly. This is phoneme. I've been pronouncing it phoneme or something, I said. I believe the correct pronunciation is phoneme. Still not 100% sure on that, but this is if you type this into Google and just phoneme lips, you get a bunch of these charts. So I use multiple ones just because some of them are really short. Like this one is really, they only have 1, 2, 3, 4, 5. This has 10. And you need a lot more of them. Well, for my situation, because my facial deforming HDA has all 41 phoneme values. Like as I've mentioned in the last live stream, this, if you create a CHOPS net, go into it, type phoneme, this node, drop this node down, which is this one here. Come over here to the help. So select this node, come over here to the help box. It'll bring up the Houdini built-in help thing. Takes a while to load. Just give it a second. Scroll down. This is what I have a unique lip mouth shape for every single phoneme value you see listed here. It's slightly modified for every single one because some of them are really similar. So in English, you have your A, I, O, U vowels. Some of them are really similar, like time and dime. Like these two, time and dime. So they're gonna have. You're gonna notice if you look up the phoneme lip value, it's gonna be almost exactly the same. You're not gonna see something too different. And in my facial deforming tool, I modified the time and the dime just slightly, just made it a little bit bigger, open mouth, wider, smaller, just a teeny bit, just so that it looks like he's talking. So artistically, it's more convincing. That doesn't mean it's 100% accurate. If a professional looks at it, looks at the animation, they're gonna see like it doesn't make sense. So this is artistically convincing for what I've set up for the phoneme values in my HDA from last week, and I'm talking about this guy. So the facial phoneme for CHOPS. This just makes it easier so you can get something out of the box right away. So you can like make a mesh have lip movement right away. After, well, okay, you have to still plug in these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values in it. So you just click this and choose the corresponding spot on the lip. And these labels correspond to the charts on this page here. So you'll know where it is in the lips. So you need to tell the HDA where this is. Where is the mouth upper left middle one? What does that correspond to? So that's what this is. This is a nice reference page. So that was all in the last live stream. Today we're going to focus on CHOPS. And after that, after we get the CHOPS set up, I'm going to take this a little further and show you how you can use the same CHOPS network or a similar, like, the similar CHOPS node to drive dance animation. So your mesh can dance with the music. You'll see that it's more on the beat. So his hands or movements is more on the beat. So it looks more realistic. But first of all, let's go on to CHOPS. Okay, let me actually go here. Okay, so that's what this is looking from the last hip file. Come here, and we're going to build all this. Well, we're going to first, before we build this is bringing the CHOPS into the SOPs. So this is the SOPs network. This is the CHOP network. So it's very similar like .NET. You have it's .NET, the dynamic world. Well, CHOPS has its own CHOPS network. So this is bringing everything into the CHOPS into the SOPs so we can build a visualizer. Oh, there it is. Well, let's, okay, let me change the background. Okay. Oops. So this is bringing it all into SOPs. That's what this part is. And the CHOPS is responsible for analyzing your audio file. Another tip to give you, when you're setting up CHOPS and you want to listen to the audio while it's playing in the timeline, come over here. So you'll see Houdini here. Come to the right bottom corner, right here where you see the speaker. You choose this. You can click real time or you can click scrub. I usually just do real time. You can play whatever you have in the CHOPS, or you can play a file. What I usually do is just pick a file and then just pick your MP3 file. This plays nicely. Like this one doesn't have to be encoded in AIF. Because I did mention in the last live stream that I was using MP3s at the beginning and it kept on crashing my Houdini. Although that hasn't happened ever since. I'm not sure it's because if I switched all my files to AIF, but I haven't seen it crash yet. So this can play an MP3, I believe it is. Oh, this is playing AIF. Okay. So if you do see it crash, if you're using MP3s and you do have Houdini keep crashing, just double check if it's AIF. And then if it's not, try to translate the file to AIF. What I use is Audio Premiere, and I just load the MP3 on it and then output an AIF file. So search online how you can convert files, file formats for audio files. Okay, that's my little 2 cents. And once you have that, so once you have this real time and you go like, you can just close this panel and then you just play your timeline. The music will play with it. Now there is a delay. You can set a delay here. Delay 0.2 of a second. I believe this is in seconds. I usually just do 0 delay. So it plays, so it's more in sync with my animation. There is a slight problem though. If your animation is complex, if you have a very complex setup in your node network, the animation will play slower than the sound, and the sound will try, this audio panel will try to keep it in sync. So it'll keep on repeating that section. If you have like, it'll be like dun dun dun, and it'll go, and your animation's not there yet for the 4th frame or the 5th frame, it'll just go back and play dun dun dun. So you'll see something choppy. It'll be like repeating the same section until the timeline catches up. So that's something to be aware of. What I usually do if I really do have a really complex animation playing, like a complex scene playing, and I can't seem to synchronize the audio file during the playtime, I just render out a flipbook load it up in Audio Premiere, and then play the sound with the flipbook animation. And that way everything's synced up because it's already rendered out. Okay, now we can start on CHOPS. Okay, so we don't need this. This was just for reference to show you how you can get access to the 41 phoneme values that I've been using as a reference. So this is what we're going to set up here. I'm just going to launch it in my notes. Okay, so let's just delete everything here. Let's start from scratch. Now I'm just going to use audio files that I've pre-set up. So the first thing you have to do is you need to create your phoneme library. And that goes back to that this node again. Gonna bring up that chart again. In order to create your phoneme library, you have to get a microphone, and because it has to be your voice. If you want Houdini to recognize your voice, you have to create the phoneme library using your voice. And what Houdini does, it looks at your phoneme values and your phoneme library and goes like, okay, I'm going to remember these sounds. I'm going to remember these syllables. So what it's going to be is you're going to record, well, silence, there's nothing. So you're going to be reading this list. You're going to go beat and give it a pause for a few, I don't know, count 1 second. Give it a pause for 1 second and then read out the next one, bit. Gate, try to record this whole list in a quiet room so there's no background sound, background noise. And this makes it much more accurate in the whole process. So let's for all of those that are members that download the HIF file, I've included that phoneme library file, that audio file, with this whole thing. It's in this link here. But that's not very useful for you if you want to do your own lip sync project, because that's my voice. So that's not very useful. If you want to create your own phoneme lip sync projects, you're gonna have to record the phoneme library with your own voice. And after you record that, you can bring it into the CHOPS network by dropping down this file node. So I'm just going to load this in. So the one that I did was over here, 41 phoneme values, and it's in AIF. Okay. So we don't see anything here. Let's put the render flag. Nothing. In CHOPS, you're going to have to open up a new panel. Come to here, new panel tab, viewers, motion FX view. Click that, and you're going to see this. Let me make this larger. We actually don't need Oliver. So this is the audio file spectrum. Now let's see what happens when I play it. Now you're not going to hear anything because I don't have this turned on. I have this turned off. But you're going to see it loaded here. You're going to see an audio file loaded here, which is this, like, you see this audio spectrum graph on the timeline. That's the audio spectrum of this one that you loaded in here. That's this file. So it's not the one that you have here. That is, you have to be careful with that. Actually, let's make this sync up. Let's just do both. Same file, so we know. So it looks like it's the same. So here you see that I have I'm reading out that list, that word list, one word, and there's like this nothing here. There's a pause, and then the second word, there's a pause. The third word, there's a pause. This allows Houdini to analyze the audio. And if I play this, I won't know where it is in this audio spectrum over here. So put your mouse over here, hover the mouse over this, the chop next, the motion FX view, and hit T. That'll bring the timeline over here. Let me make this a different color. Okay, so the blue is your timeline right here. If I play it, it's going to play with this. So let's zoom in. So you can see this is playing it. And if you want this to like resize correctly, you can click one of these. This will stretch it up. Stretch it there, and then there's the home button. Not much. It doesn't resize that well when your audio is too long, so that's the only downside. Okay, after you have your phoneme, so this is the phoneme library. So after you have that recorded, take a look at here in the details. We have one channel. So the CHOPS net is based on channels. This is one channel. It is running at 48,000 samples per second. That's so audio files is samples. How many samples you're going to have in 1 second. So when we're doing like animation, we have frames per second. So this is sort of like the same thing, but for audio, it's 48,000 samples per second, because audio, you can fit a lot more audio in 1 second than you can with frames. But we actually don't need that much. You can turn it down. If you have a slower computer, this may hurt you in when you have the whole thing set up. But I'll get back to that. I'll get back to how you can turn this down. First of all, I'll show you how to set up the whole thing first. And we'll go back to how to change the samples down for those of you that have a weaker computer. So one of the main tools we need is a voice split. What this does, it will split those. Let me put this down first. It will split every single of these audio samples, the pause being the divider. So that pause is very important, being the divider. And it will put every single that sample, this little bit of word that we have recorded down, that syllable, on its own channel. So watch what happens when I connect this up. So another thing about CHOPS nets is that once you put a render flag here, you have to turn it off over here manually. So it doesn't automatically toggle over. So you have to like switch it on, switch it off. And you can off, and then on. So what the voice split does, now we have like, there should be like 41 of these. There's like 90, sorry. There should be 41. Let me pin this automatically here. So I know there's 41 words that I want Houdini to detect, because I'm the one that read that list, that 41 list of words. So I know that this is not looking right, since it's like 90 channels. What it's doing is taking every bit of these sample words that I'm reading out and putting it on its own channel. So there's 90 of it. It's over detecting some of the stuff. So what you can do here, select this voice split node, come to the silence level parameter and adjust it. Make the silence level a little higher. Okay, let's see what happens. So there's 82 now. Okay, let's as for the minimum pause word length, this is in seconds, I believe. It should be in seconds. Sorry, just give me 1 second. I'm just gonna get a glass of water. Okay, so this should be in seconds. Let's turn it up a bit, because some of my pauses is really long. You can see that there's a huge gap here. So let's turn it up just a bit. Let's see what happens. Okay, 70. That's improving a bit. Oh, sorry. This is the minimum word length. This is the minimum word. So each word is how long. It's asking how long is each word in terms of time. So each word is pretty short. Actually, let's turn that back down. The minimum pause length, that's what I was looking for. That's the gap. How long are these gaps in between each word that you read? So that's this one. I want to turn this one up. Let's turn it up a bit. Okay. I'm just going to keep adjusting this until I get the right number. Silence level. Okay, so now we're down to 34. I've gone overboard because I know there's 41. So let's go back down. Too much. So in between. Let's do... Whoops. 28. 25. I think this needs to be lower, and then do 22. Okay, I'm just gonna cheat and look at what I had before. Okay, so the one that I had before was 1.55 and 0.1. I kept it at channel 1 names. Okay. This is 80. Do I have the right file? Let me just double check. 82 channels. Oh. Okay. Before we do all this, I forgot to delete the second channel. So the recording, the one that I recorded in, here, the phoneme library that I recorded in, because my microphone has stereo enabled, there's 2 channels. So you're gonna, you don't need both channels. You don't need the left and right when you're creating your phoneme library. You only need one of them. So what I did was delete one of them. Because the right and left is the exact same thing. You don't need surround sound for this. So let's come over here and let's just drop down the delete node and just delete one of the channels. I'm just gonna delete chan 1. Whoops. Okay, let's take a look. So we only have one audio channel. So that's all I need. I don't need stereo. Mono is fine. Now hook it up to the voice split. Remove the, you have to keep flipping the render flag on each node, which is really, that's one of the things I don't like about this. So now we have 41 channels. Okay, so that looks a bit more, that looks way better. Now each channel here again is the word that we read from this list. Maybe I should just keep that list up. So this is just for reference. So this is the list that I'm talking about. Each little jump here in the graph represents one of the words that I'm reading out here. Now it's important that you record your phoneme value in the correct order. So if you're using my HDA, if you're planning to create your CHOP network in the intention of using my HDA to make your mouth move, you need to read that list of words in the order that I provide because of the way that I've set up the CHOPS in here. So if you drop down, install my HDA, and then just drop down the facial, this node, facial phoneme for CHOPS. Come over here. I've left a really large note right on the node just for convenience, and it's important that you read it in this order. This is the same list. This is the same list of words. It's just in a different order, in the order that corresponds to my HDA. So what you can do, just right click this node, come to parameters and channel and parameters. So you can have this floating panel around. And then you can go back to your CHOP network. And you'll have everything here on your screen. And it's important you read this from top to bottom. Okay. Voice split here. So this is setting up the phoneme library. Now we have to feed in the phoneme library into a node called voice sync. Let me do this. Medium. So we're a bit more organized. There we go. So this goes to... Oh, I could have just dropped down a null. That was silly. Yeah, I could have just did that. Okay. So this phoneme library is what this voice sync node needs. And what this voice sync node does, it takes some audio input. Just gonna have this audio input, which will be your speech audio, whatever you have talking. Like, it could be directly like the audio coming from directly from your microphone. If you want a live feed, you can drop down an audio in. Drop that down. And this will trigger. So I'm going to turn this off. Let's see if we can do a quick demo. Doot, 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 doot. Okay. Oh, there it goes. So it's recording what I was reading out. My doot, doot, doot. Let's see. Doot, 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 doot. Channel 1, channel 2. Okay. "24 seconds per frame." So you can, if you select this node audio in here, you can select your line in stereo. You can choose mono. That would make life a lot easier. So you only have one channel that comes out. Let's see, levels, audio, line mono, 24 frames. I believe 24 is good enough. If you want better quality audio, you can amp this, like you can pump this number up, but it's going to slow down your computer as you pump it up. So we're just going to leave it at 24. Now what you can do, if you don't want a live feed, because I don't know how you're going to record this though. Like, I don't know if Houdini has any audio recording nodes. I usually use a different app to record the audio and then feed in the audio file using the file node. So I'm just going to feed in something random. And this will be your text speech one. I'm just going to use the script that I did for that Oliver fishing scene. So you can see here, this loads it all up. There we go. Okay. So this is your audio input, which is your text or your speech. You've put that into the first input, which is your audio source of the voice sync node. The second one, it's looking for the phoneme library, which is the middle one, the middle input, the second input. Now let's take out the render flag. Put the render flag on this guy. It'll cook for a second, just because it has to analyze the audio. And it has to detect, so as you can see on the bottom, it says detecting phonemes. So it's trying to detect all the phoneme syllables that you fed in from the library. And it's detecting it from this text speech audio file, this script that I'm feeding into it. And what's going to come out is that you're going to get the same 41 channels of phoneme values. It's going to be 40, I believe it's 41 channels of phoneme values, including this silence one. And every one of them is going to be on its own channel. So again, it's going to be on its own channel, and you're going to feed in every single channel into the SOPs. And that's how the SOPs will know, oh, that's how the first syllable is detected, because it triggers something in the first syllable. So right now, let's fix the naming first. Output chan. This is just, it's going to get chan 0, chan 0. Guess that's okay. But okay, besides the name, I'm getting a repeat here. Okay, let's do a rename to get rid of that, because I don't like it having this chan 0 chan there, this extra chan. So let's drop down a rename, hook this up to the first node. Again, flip the render flag, really annoying. So chan to chan 0, or chan to, let's see. Oh, I think I know why. This is coming in as, I forgot to delete the mono again. Keep forgetting to do that. So the input, my input speech, again, it was recorded with the stereo. So there's two of them here. So it's confusing. It's confusing this node right now, because the library is based on mono. This one here is based on stereo, but then we deleted it, and so we have a mono channel, and I need to do the same thing for the speech so it matches up. And now it has to analyze one more time. Sorry about that. CrossMind Studio. Hello. You have a check mark beside your name. I wonder what that means. Sweet. Okay. Give it. Okay, it's almost there. I should have used that shorter audio file. Okay, maybe I will. Because this is gonna be doing this every single time. Let me pick something small. Text to speech 2. Let's try this. Okay, that was a lot faster. There we go. Okay. Now we shouldn't have that. Okay, now it looks right. Chan 1, chan 2, chan 3. It's because there was a mono. It was feeding in a stereo in here, so I keep forgetting to delete the stereo. Delete this, because we only really need mono. So now the voice sync has the correct naming, except for the first chan. So I like it so that it goes chan 0, chan 1, chan 2. For some reason, it misses the first one. That's all right, because we can rename it. So that's what this is. I'm going to rename the first channel to chan 0. So now we have this ordered nicely. So this will come in handy. This nice organization of the naming will come in handy when we bring everything from CHOPS into the SOPs. Okay. So you can see here in the graph, there's multiple variety of colors. Each unique color represents a channel. So we should have 41 of these, 41 different colors of graphs in the Motion FX view. Now let's just look at one of them, just because this is really hard to look at. Throw down a delete. So the delete node in CHOPS works very similar to the blast node in your SOPs. So you can delete, let's focus on chan 0. If I go like that, I still see all this stuff here. That's because you delete scope channels. It's deleting the channel 0, but I want to delete everything but the channel 0. So it's very similar to that blast node where you can delete non-selected. So that's what this is, non-scoped. And it'll isolate everything but the channel 0. So we get this nice view. This is, so it's detecting the first syllable that I give it, which should be I'm trying to get this list. Where should be this syllable here? Beat. So it's detecting this beat in this audio file that I'm feeding into it right at this time frame. So let's around here. 88. Oh, let's flip this over too. So the graph in the timeline matches up with what we're seeing here. I use text speech too. Okay. Okay, so that's right around here-ish. Let me turn off the audio. Around here-ish. Okay, that looks about right. Let me color this black, because this is only going to be used for reference. Let me try different. This is a quick way just to debug if it's actually working, if it's actually detecting anything in your text-to-speech, in your input file. So let's try a different channel. 1. Okay. That should be the word bit. So it's detecting bit every single time in this input audio file. Here, here, and here, which is around here, here, here. So this is a quick way for you to sort of verify if everything is working. Now, what you can do here, just because everything coming out of this whole thing, of your whole setup, is very blocky, is very like up and down blocky, you may want to filter the audio signal. And you can do that by dropping down a filter. And what I usually do is I throw down a Gaussian model here, which Gaussian is usually used to smooth things out. So you have this really blocky thing here. This is literally 0 or 1. It's detecting it or it's not. So it jumps right away. You can picture the mouth on your mesh moving from one vowel to another. It's just going to jump to that vowel. There's no blending. There's no small slope slowly transitioning to that other syllable. So that's why I usually put down a filter node using Gaussian and try to filter it out just a bit so it smooths it out. So you get a bit more transition. So it goes like 0.5 value when you reach that bit, or that when it detects a bit or bite or gate or fat or whatever that vowel syllable. So you can see here like this one compared to this. This is very blocky. So after you filter it, it's a little there's a bit of slope to go around with. You don't have to worry about it not going all the way to 1, because you can always amp it up. Once we get to the SOPs, you can amp it up there, or you can amp it up inside the CHOP network. I usually like to put a parameter on the SOPs, and you can adjust the thresholds. And that's what I usually do. That is more convenient because it's right on the SOPs. So I just set up the CHOP network and I don't have to touch it anymore. Now, the next part, so we're practically done with the CHOP net. This is the main thing in the CHOP net. The next thing we need to do is bring this into the SOPs. Now, first of all, we're going to use, I'm going to add the filter in a little later because I want to show you what it looks like without filtering. So we're going to use this one. So we're going to use this guy. And let's make that audio visualizer first before we hook it up to the entire, before we hook it up to the Facial Deforming HDA. So we're going to recreate this thing here. Let me delete that. Now, in order to create that visualizer, I just want something really simple just to debug or verify if everything coming out of this CHOPS is working properly. So let's just put down a grid. I'm just going to recreate those little squares that I had before. But this is way too big. So let's get something smaller. Okay. We don't need that much topology either. This is a lot of topology. Not going to be used. So let's just do it, reduce it. Just one square. That's good enough. Dark. Let's go back. So we have 41 of them. So I want a bar for every single phoneme value. So there's like 41 of them. Let's do a simple copy to points. Oh, sorry, copy and transform. It's 41, and I'm just going to move it over. There, that's good enough. So I just moved it over here by 0.2. You can move it by 0.1. This is side by side. 0.2 is good. Now, this is where it gets a little funny. So here, we're going to have 163 points. So there's 163 points just because every square has 4 points. So every square here has 4 points. So it's 163 points. Now, in order to bring all of the 41 channels from the chop nets into the SOPs all at once, we can use this channel node. Drop down the channel node from the SOPs level, and we hook it up. Now, this channel node is expecting sort of like one channel per 1 point. And it'll bring in all of the channel data into every single point. So this is not going to work out for us here, just because here we have 164 points, but we have 41 channels because we have 41 phoneme values. So what we want to do is we want 1 point per square. And what we can do is assemble it, pack every single square into a packed point. Create name, create pack data. So the assembly node, now we have 41 points. 1 point per square. Perfect. We can always unpack it later. So this is so that it works well with this channel node. And the channel node can bring in all this ChopNet data, the 41 channels, into the SOPs level, 1 channel per point. So 1 channel per square, which is exactly what we want. So here in the channel node, come over here, and we want it animated. So we want it to be pulling the data every single frame. The channel scope is asking us what channel we want. So this is chan. It's going to figure out the 1, 0, 1, 2, 3, 4 at the end, like the number at the end of the channel name. So the attribute data that we want to feed in, this can be anything you want. You can put it at P. I believe it's PY if you want to use it to change the level of the height. TY. I believe it's TY or PY. But what I usually do is here. Channel value. And it's asking us what chop net. So you just grab your chop net setup, drag it to this chop parameter. There you go. Unknown channel value. Okay, so the channel value has to exist. So it's saying, what is this? I don't recognize this. I don't see this channel value. What we're going to do is create it. Attribute create. Come here. Just going to copy this name. Just going to put it in here. It has to be a point because we've already packed all the data into in every square into a point. So we want a point class. Float, that's good enough. That's default 0, value 0. It doesn't matter what the name is. The default number is. Channel value attribute scope point. Let me check channel value here. Chan2 not found. Let's take a look. Oh, this brings us to the next thing. Let's see. Output. Here, I have to put the flag over here. This is the output flag. So, let's go back here. The chop net here. Inside the chop nets, this output flag is very important. It will determine what this setup is outputting from the chop net. So it doesn't matter where you have the render flag. This render flag can be anywhere and it wouldn't make a difference. You have to have this output flag selected. And later on, I'm going to go into this export flag. So the chop nets is very different from your dynamics and the SOPs level. So now it's gotten rid of all the errors. We can take a look at here, the channel. Let me isolate this. So let me isolate that. And I'm just going to scroll it through. You can see it flickering. I don't know if you can see it flickering. Oh, there it goes. See? The values are going up and down. So it's detecting, that's detecting channel 39, the channel 39 syllable at frame 46. So that's what happens there. So now we want to translate this information into the bars going up. So let's put down a poly extrude. Oh, before that, we can actually unpack the data. But let me put down a null just here. So you have channel values. So this is the channel values is going to be fed into my facial deformer later on. So let's just finish the audio visualizer first. So the audio visualizer will help us debug, verify certain things, just to see if it's working properly. Just because we can't see the sound, it makes it a little difficult to verify. Having a simple visualizer helps it a lot. So let's unpack all our squares so we get everything. And we can start extruding these squares up according to its channel value that we've grabbed from the attribute. Here, let's transfer the channel value. Okay, awesome. So we got that all back. And let's take a look. We have all 164 frames. Good. Points. Now let's poly extrude this. Now poly extrude has this nice little feature over here where it can extrude by attribute. So if you go to the local control, you can click this distance scale to basically it will extrude each square or each primitive according to whatever attribute you throw in here. But if you look carefully, it's looking for a primitive attribute. So we have everything on the points. So what we need to do is attribute promote the stuff that channel value from the point onto the primitives. Okay, now we have to switch this over to primitives. So it's over in the primitives now. Now in the poly attribute, let's call this channel underscore value. And it should extrude properly. If only this wasn't so small. Distance. Sorry, I have to give it a distance. Distance scale. It's scaling. What this is doing, it's scaling this number here. And scaling 0, multiplying by 0 is always 0. Yeah, there you go. So this is like, as long as you have a distance here, something above 0. So what it'll do, it'll take your distance scale, which is this channel value here. So whenever you see, whenever you see this 1 here, this 1, it will get multiplied to this distance. So if you want everything longer, you can see this will go longer. So this is more like a global scaling parameter that will scale all the bars. This will give it, like, if it has a different channel value, which I'll show you in just a bit when we put down that filter node, because we're going to get that slope. So this will give it, that filter node inside the chop net will give it a bit more gradual transition. So we're going to see that in just a bit. So this is a very simple visualizer we can use to debug if anything is working. So what I usually do, just to check if it's grabbing all the phoneme values, is to look at the first or the first square or the last square and see if it ever moves. So I know that it's getting like something. Okay, so that was quite fast. Okay, so it's getting the last one. So I know it's detecting something all the way through. So usually that's just a very quick check. Like a quick sanity check. Cool. All right, let's do this. Now let's add that filter node. Because right now we don't have the filter node. Remember, I put the output over here with the output flag here. So what we can do is just flip the output flag over here. That's all we really need. But to be more organized, we probably should just drag it over and connect it properly. And then put the output flag over here. That's probably more organized. Just be aware that the output flag does matter in the chop net. Okay, let's take a look. So you can start to see that, see, this is growing slowly. You can see it goes up, down. So it goes up slowly as opposed to what we had before. So I'm just going to jump the output flag over here. So this is no filtering. Over here, no filtering. And I want you to see the difference. So it's either up or it's down. So it just jumps over. There's no gradual transition going up. And that really hurts the lip sync. So I'm going to put it back over here. We have that gradual up and down. All right, I'm just gonna go here and put an out so I can find this node more easily. Now this is what we're gonna feed into the Facial Deforming HDA tool that I created last week, or in the last stream. So let's go back to the character lip sync over here. Now I've already set this up from the last time. So this object merge is grabbing the out channel values, which is what we just created. So let's go there. That's this guy right here. So audio channels here. It's grabbing the grid as well, but we're not going to be using this, and this doesn't work because this is before the extrude. So if we go here, this is before the extrude. The extrude is here. But we're not going to use this. We just need the data that's coming out of this. We just need this point data, these attribute values. And here I wrote a little wrangle here to overwrite and test the silence, which is not needed right now. So let's just ignore this. So if you all downloaded my facial phoneme for CHOPS HDA tool, just come here, drop this node down, and let's just hook this up. Give it a second, because it does have 41 phoneme values, which has 41 different mouth deforming shapes. It does take a while to load. Okay, let's forget that. That's taking way too long. Canceling. It does take a while. Okay, let's just use this because I have this already set up. It's the same value, a same node. And I already have the mouth points already set up too. So if you want to learn how to set up this stuff over here, the mouth, take a look at the previous live stream. That whole live stream is all about this. So after we have all that done, let's just take a look at what it does. See if it works. Okay, something's wrong. Radius to side. Let me just take a look at my notes. Corner. Channels. Point Chan. Oh, it's important that you have the channel named Chan. I actually should fix that in the HDA. So, let's go back to the channel here. Over here, we had a choice. What do you want to name your attribute? Where do you want me to stick all that channel value data? What attribute name? So I gave it a name of channel value. In my HDA, I only recognize Chan. So I'm going to fix that. I'm going to make it my HDA a little more flexible. I'm going to add a parameter so you can actually choose what attribute to pull off. So right now, let's just use Chan. So right now, everything's coming from the Chan in here. So let's just double check if the visualizer is working. Poly extrude, Chan, we have to fix everything here. Channel value, Chan. It's everywhere. Chan. Okay, let's take a look. Sanity check this. Okay, so there it is. Let's go back here. Let's go back to the lip sync. It's cooking again. Okay, let's come here. This should be a bit better. Double check. Okay, Chan. Here. Okay, let's do this. Play it. Cooking. It does take a while to load. Okay, I can see the mouse starting to move. So we're just gonna have this run just for a few frames, just to show you that it's working. It's pulling in the channel data from the chops and then directly blending the different mouth shapes together. Okay, there it goes. Okay, I think that's enough. Okay, so you can see it starting to move. You can adjust how large to move its mouth and how I've given you simple deforming radius, deforming scale to make if the movement is too wide, like over here, it's starting to look weird, then you can actually adjust it. Does take a while to cook though, every single time you modify one of these. Okay. Just gonna take a look. Is there any questions? Scale Gitsophantic, I believe. Hope I'm pronouncing that correctly. Okay, so there it goes. So I'm going to refrain myself from modifying this. I will add another update to the HDA. Like I might have a parameter here asking for the attribute name that you did in the channel value to where to pull off this attribute value, this chan. So this chan doesn't have to be chan. Right now it does, but I'm going to make a change in the HDA so that all you have to do is just feed in a name here and add an extra parameter and feed in a name, and it'll pull off that name. So it's so it can be a little more flexible. So let's do something here. One way I'm going to test this out. So I had pre-cached. So I had pre-cached some lip sync, some random lip sync here. It's just simply opening and closing his mouth. That's all this is doing, nothing special. I cached it out. And we're going to use the CHOPS net to drive some dance movements. So that's probably a little more interesting than this. So that same file. So let me show you the setup I have in my hip file. This is the hip file I have. The one that was from, let me put this side by side. That's probably better. I believe it's this one. Yes. Okay. This cache file and this cache file is the same cache file, and it's going to the same geo folder in here, but it's two different hips, so that's very important. This one on the left is the name's way too long. It should be this one on the left, and then this one on the right is this hip file. They're both reading and writing from the same geo folder. This allows me to reuse the same file cache between hip files, which is super convenient. I always use this little trick to transfer animation data from one hip scene to another hip scene. So let's just take a look on the left side. Drag this out. So I don't have that many cached out. I only have like 240. Let me make this smaller. All that. And that's going to be blended in with the dance movements. So this dance movement is completely powered by ChopNet. So let's take a look. Now I already have this teddy bear rigged. Now the rigging process I'm not going to go over just because I have tons of KineFX rig tutorials in the past. Let me bring that up. So if you want to learn how to rig characters, that will be based on this guy here, this one, and this is crowds. So these two will be, this is really all you need. This one over here is all you need to how to rig KineFX. I will double check why this is not working. It must be a broken link. I will double check that. KineFX tutorial. But if you go to my YouTube channel, don't want to leave you hanging. This one. So you'll see that it's this one right here. So that'll teach you how to rig characters. That's what I've done here for the teddy bear character. And from the full body IK. So starting from the full body IK, you have the skeleton exposed, and you can start animating this in order to get the whole thing working. You drop down a rig pose node. This will give you access to the skeleton. So just here, Select this node, mouse over viewport over here, press enter, click one of the bones. So say I want to make his arm wave. Move it up. Okay. And this has to be hooked with the bone deformed node. It's all the way on the bottom here. So I'm just going to put another one over here. Bone deform. And the bone deform. Geometry over here. Remember, this first input needs the geometry from the mesh that contains your weights, your mesh, your bone capture weights. This is your rest skeleton, non-moving skeleton, which is this one over here. This full body IK is the one animated. So we've actually made his arm go up. So that goes into third input. And let's take a look what it looks like. Okay, so his arm's up. So a nice way to animate this is to have the render flag on the bone deform, select the rig pose, and you can actually see both things. You can have the best of both worlds. And what I do here, so this is only for reference, so let's just, we're not going to use these two. Okay. So what I've done, I've used that concept, and I've hooked up the rig pose node, these parameters. You can see that once we start making him wave his hand, we get this panel that's created. It'll create a new panel every single time you click on one of these bones. So let me click on another bone. Let's click on the other side. Arm R. Click this. It'll create another panel here. It exposes all the transformations for you. You can rotate, transform, scale, whatever. What I've done is I've hooked up these rotations to the chop net coming in. So here I have a separate chop net. This is very similar to, is actually more simplified compared to the one that we just set up. The one that we just set up is for voice recognition, so you can actually recognize syllables in your voice. This one is a lot simpler. Oh, we don't need that. I downloaded an audio track from a piece of music from the YouTube audio library. So that's like, if you just go to the YouTube audio library, it's all of the songs on there are open source, so you can use it for whatever. And I don't think you need attribution too, so you don't have to even give credit. But that's up to you. So just use it for whatever, but you're not allowed to sell it. It's free use for your own projects. So it's open source music. So the one I've used is the Runaway, which is the one that you hear in the promo video that teaser video that was released yesterday. Now this is an MP3. So as I said, sometimes it works for the MP3. Sometimes it crashes my Houdini. I'm not sure why. But use the MP3 if that's for your convenience. And then just try it in Houdini. See if it crashes. If it doesn't crash, then you're okay. If it does crash, convert the file to AIF. Now this comes as a stereotype again. But the key is that it's 44,100 samples per second. I believe I did a resample here. Let me pull up the motion FX because that makes more sense. I'm gonna take that out. So we're just gonna get into the export. Let me delete that. I've changed it to 48 samples. So this is significantly reduced it down to 48 samples per second compared to when it was incoming 44,100 samples per second. A significant reduction. This makes it go a lot faster on my computer because when I was doing it at the original sample speed of 44,000, it was taking a long time to analyze the spectrum. So reducing it down does help me. So that's one of the things that I wanted to get into, is how to reduce it. Just give me a second. I'm just going to pull up my notes. And we're just going to delete all this. And we're going to start all over. So I can show you a live build. So we're going to put down a resample node. Put the render flag here. Now the default is 24. I believe I was using 48. So that's a little bit. It's still a like this will make the computer go faster, basically. Better performance. Okay, next, let's put down a filter. Just because this is very spiky. Making Oliver dance to this spike. Actually, let's do it. Let's just do that first so you can see what it looks like. Now, how do I get this data? How do I get this audio spectrum into CHOPS to make his hands and to make Oliver's hands and legs move? So let's take a look. We have channel 0 and channel 1. Well, let's just feed in one of the channels. Take one of the channels. Now there's something in CHOPS called export. This will allow you to export directly to one of the parameters and overwrite one of the parameters in the CHOPS. So this will allow you to overwrite it directly, which is incredibly handy. So we don't have to have that point data. We don't have to use that prepared. You know how I was doing the grids and multiplying the grids to 41 of them and packing the data and all that preparation work? This makes it a lot easier. However, this export node is only good for like one parameter to overwrite one thing, which is perfect for the rig, just the power the dance moves. Now, this is the important thing about this is that you need the export flag. So before we had the output flag. Now it's important that we have the export flag on. So let's turn that on first. Otherwise it won't read this. This data will not leave the CHOP net. Okay, so it's asking us, what do we want to export out? Well, we can pick it from this drop-down list and just pick channel 0. What node do you want this data to go into? So let's go back up. So I've already had stuff set up. Let's go back to our little test here. And let's overwrite that shoulder left, which is this. So let's overwrite this. Let's overwrite this one. Let's have it power this movement here. Let me just zero it out first. Okay. First of all, come to the rig pose. What I usually do is edit the parameter and add an extra parameter. Float. Drag it to the top or the bottom, wherever you wish. I just usually name it channel, so I know it's always named channel. That's all you need. A float, channel. So that's this thing that we've added right here. So rig pose node. Select this, Control C. So we're going to copy the path to this node. Go back to the CHOP net. The export node, paste in node. Where do we want to export it to? Well, this rig pose node. Now, what's the path? Well, I just named it channel. That's the name of the parameter. Let's go back. Just want to show you. That's the name of the parameter that we just created up here. So you can see that it's turned orange to let you know that it's working. So let's just drag this along. You'll see that the numbers are coming in. They're relatively very small, but that's okay. Let's just hook up the whole thing first. Copy this parameter. Copy parameter. Come to the rotate. And let's just paste in a link. Paste relative references. Okay, and then just play it. You're not going to see much because look at these numbers, 0.0002. So what I usually do is I throw down another parameter right beside the channel and I call it threshold. In the channels, I'm going to make it default to 1. So it always defaults to 1. So this is default value of 1. We're going to take this, copy this parameter. Oops. Sorry. Copy parameter. Come down here again. Let me drag this out. What I want to do, take the channel, multiply it to my threshold. So paste, oh man, sorry. Okay, paste relative references. So you get channel threshold. What this will do, well, right now it's multiplying 1, so that's not much. Let's take something, okay, where it's a little larger. Okay, so we have some value here. So let's make this threshold like 100. Okay, so that's a bit better. So you can see the arm slightly moving, but that's not even close. It's 500. Okay, that's a bit better. Let's just play it. Let's see what happens. So now you have your arm moving with the music, with the audio spectrum of the music. You can see it's very shaky. The movements are very sharp. It goes up, down, up, down. If that's what you like, that's cool. That's where we get into the filter. Let's go back to the channels. So here, you can see this audio spectrum. It goes up, down, very sharp. Because there's 2 channels right here. We're only using channel 0. So let's delete this for visual purposes. Channel 0. So I'm going to go non-scope channels. So this is what it looks like. It's very sharp is what I'm trying to point out. That's resulting in sharp movements in the arms. So I want this a bit more, it looks weird. Let's drag this down. Let's add a filter node. Untoggle the flags, put the flag on the filter. And it has filtered it too much. So I want to see both of before and after. So you can see that once I select the previous node here, I can't see the filter flag anymore. So what you can do, the last node that you turn on the render flag will be the one on the top in the graph. So let me untoggle this, toggle it back, then you can see it. Now you'll see that it has reduced it too much. This large, the large spike has turned into this little thing here. Let me actually change the color. That's terrible. White, is that better? Okay, white is better. So you can see that's a little too much. So we need to adjust the filter. Go to the filter here. Gaussian is usually used for smoothing things. So that's something we need. I'm going to reduce the filter width to 0.22. That's because that's what I used in my test, in my notes. And that's a lot better. So let's turn this off so we can see this. That's a lot better. Let's take a look at what it looks for his arm. Okay, now it's getting jaggedy just because we've reduced it down. You can see how much we've reduced that spike. So I usually like to go to the CHOPS level because I have that threshold here. I can multiply it in here. So let's do 1,000 instead of 500 and let's play it. Let's see what that looks. So this little thing, now it requires a bit of tweaking depending on your music and the movement and the dance movement that you want. But this is the basic concept of making his limbs, the KineFX rig, move with the music. Now what I've done here is I've used that technique over and over and over and over again to make the hip swing and then make the arms. So let's actually take a look. This one is a bit more complicated. It uses a rig attribute VOP, which I will cover in a later episode of the lip sync miniseries. It will be the one after this, just because this is a little bit more complicated. So it's out of the scope of today's live stream. So let's just ignore that part first. Let's look at the arms. Oh, I have to hook this up because we redid the chops. We redid all this stuff. I have to bring in all my export nodes. So you'll need an export node for every single, okay, this is not being used. So let's just ignore this. In fact, I'm just going to hook this up like this. So this part is completely ignored. So this arm control here, I used an IK chain. I'm just going to get into the IK chain just a second. But here, I don't have this hooked. We lost that orange data over here. That's because we recreated the chop net. So let's add an export. You'll need an export node for every single parameter. Let's add, in order to add the export flag on both of them. So once I click this, you lose the export on this one. So then this one will not get the movements. It won't get the channel data. In order to get both of them exporting, you have to select this. Well, you can select both nodes. That's one thing. Or you can select this and then hold down Shift on your keyboard and then select this one too. Or just select both of them and then, select it like that. Either way works. So this is the arms. We just repeat that again. Arms here. So Control C, and let's copy the path to this node. And I don't want the asterisk, I want channel 0. Path, I've called it channel. All of them are called channel, just for simplicity's sake. Okay, let's go back. There we go, we got that. And I have a threshold of 2. Let's take a look at what it looks like now. It's shaking a bit. So this is only the arms. So it has that little dance movement, a little bit of wiggle to it. What I've done here, well, let's put this aside. I want to show you what the IK chain is. I might actually do the IK chain next time, just because the stream is going really long again. Okay, the IK chain is this one. Wrist R. Okay. Wrist R. Oh, wrist R. Okay. Oh, let me just close this. Okay, hopefully you can see it. When I move this point, it's automatically moving the elbow for me. It's calculating how to move the elbow. Usually. Now let's put a rig pose node over here. Let's put the right flag over there. Without the IK chain, if I just move this, it's not, the elbow's not going to move. Nothing else is moving. This elbow will automatically move based on the IK chain that I've set up over here. So let's go here. Now you can see this elbow here. Okay, let's click this. See, that's moving right there. Yeah, okay, there we go. So I'm moving that the wrist, and it's automatically, the elbow is calculating where it should be. So that's what IK chains are. To set up an IK chain is actually really simple. Okay, I'll quickly go over it, and I'll go over it more detail in the next stream. The IK chain. You have 3 points you have to tell it in the rig. This is the one, the tip name will always be the one that you want to control. You're going to move. So that's what the wrist that I was doing. The root is not going to move. So that's usually you're going to be 1, 2, 3. So the arm is over here. That's your stationary point. The elbow is the one that you want to move automatically. You want Houdini to calculate the movement of the elbow for you. So that's the middle name. And goal name, this is usually the same one as the tip, and the elbow is the same one as this one. So I just copy whatever I have for the mid name onto here, and the wrist onto the last one. Then the wrist will be the one that I move. So you put a rig pose node over onto the second input of the IK chain. And this one is actually not necessary. Like, you don't really need this. It's just not going to do anything. Just connect the original one to this here. Let's get rid of. So your full body IK basically goes all the way down onto the first input. The second input is the controls. So I'm trying to use this wrist as control. Oops. Oh, because this is hooked onto, I have this bind it. So let me bring that back. I want to show you this. So it's moving it automatically. This arm point is not going to move. It's always stationary. This is the only one that's actually moving with the wrist. Wherever you move the wrist, this moves automatically with it. This makes it, usually people use this for keyframing animation one by one. This makes it a lot easier. Rather than moving each joint one at a time, you can move a bunch of joints by moving just one bone. So this is what they used in traditional 3D animation, keyframing it manually. What I've done here is I took that wrist and I actually fed it into the CHOPS. So I'm driving the wrist with the CHOPS. So I'm taking that procedural even further a step. So you can see that I have the same setup with the channel and the threshold here, and it's powering all this stuff with the same formula that I've had here. And it's all powering the wrist R. So I have two of them. I have the left wrist and the right wrist. So it has both of them moving on, both hands moving up and down on both sides. So you can see it shake. Let's me 20. Okay, let's go further. So this can be your basic movement. So this is actually moving with the music. You can adjust it. This takes a lot of tweaking and adjusting just to get it, make it look right. But this is the basic concept. Oh, wow. What is CHOPS? You're going to have to rewind. But the end of the stream. Is rigging in Houdini better than that in Maya and easier? That is very subjective. I like rigging in Houdini just because I'm used to Houdini. I like Houdini and it's procedural. I can make HDAs in Houdini. I don't know. I think Maya, there's something similar. You can do HDAs, but it's not called HDA. I think it's called something asset or something. So there is something similar in Maya. If you ask me, I would prefer rigging in Houdini just because I like Houdini. But you need to know Maya is industry standard, and Maya has been known to be the king of rigging in the past. I don't know about now, but in the past, Maya has been known to be, really, really good for rigging. I also wanted to ask, how much time have you spent doing work in Houdini? And is it like 2 years was your first, or whatever, how was your first 6 months with the software? Did you grasp everything? Oh, Houdini at the beginning was on and off. That's a funny story, because at the beginning, when I just first knew about Houdini, so I come from a coding background. So Houdini was like awesome for me just because I can code art. That was like mind-blowing. But the problem is I didn't know how to use the UI of Houdini. I was completely newbie. All I knew how to do was just use the transform node. So that was like the first month of Houdini. Then I saw this course on CGMA, and it was like taught by this amazing dude. I forgot his name though. He doesn't work there anymore. And the problem is he was teaching an advanced course of Vex. So I was like, you know what? I'll throw myself in the pot of fire and see what happens. I was completely confused in that course. I didn't know what I was doing. But I managed, like, I because of the coding background, because of my coding background, I got some of the Vex. So I understood some of the Vex stuff that he was doing. The problem is I didn't know anything about the UI and sometimes Houdini can be very tedious when you set up your node networks. Like you have to click this, click that, and make sure this node is in that format, and you know how it is with Houdini. So that I got really confused in that. So after that course, I didn't give up, but I did take a break from Houdini. So it was on and off for a few months, and it wasn't until recently now. So I put it off for quite a while and moved on to ZBrush, and then moved on to, like, I tried a million different things in order to find the thing that I liked. And I came back to Houdini in the recent years, basically when I started this channel. Was this when I got really hardcore into Houdini. So whatever you see on my channel is when I got hardcore into Houdini. You did fast, or was it tedious task? With what? With Houdini in general? Now it is fast. Usually I get Houdini more and easier now, just because you really need to nail down the foundations. I cannot stress this more. You really do. If you don't know the foundations, it's really hard with Houdini, especially when something goes wrong and you're trying to debug what's going on. You're going to get really confused. So I try to really nail down core concepts of Houdini and each aspects of it. But that's not everyone likes that. I get a lot of comments saying, this video could have been told in just 5 minutes. It's true, but you're missing all the core concepts. So core concepts is very important in Houdini. When you were starting, did you have any prior knowledge of coding? Yeah, I came from a coding background. It helped a lot. The coding background helps a lot. Is the chat working? Test. Sorry, I forgot to check the chat for like the longest time. I'm so sorry, Jojo. Yep. Hey, that's pretty neat, cool stuff. Just so you know, I have waited here for half an hour for you to answer this question. I'm so sorry. I forgot to check the chat. That sometimes happens. I need a timer on my desk. I highly apologize. And thank you so much for your patience. Thank you for being there. Can we take a coffee break? Yeah, I'm about to end it off actually. Can you share some of your work in ZBrush? Oh, that's on my Instagram. It's mostly on my Instagram page that I don't update anymore. Well, I do update occasionally. It's because Instagram doesn't take videos. Well, you need a third-party application to post videos, which is really annoying. So I just post it on Twitter. So if you go all the way back. Oh god. Oh my god, it won't let me scroll out. 1 second. I need to log in. Okay, there we go. Let's go all the way back. Yeah, this is all the ZBrush stuff I did. Oliver was one of the very first characters I did. And I was super into 3D printing. Very obsessed. And then later on, this is the CG era that I got into. This is some of the random things I did. Okay, some of these assets, the dinosaur assets were, I bought this base mesh bundle. So the dinosaurs were actually in a base mesh, and I sculpted from that. So I didn't do it from scratch. So just to let you know, this motorcycle I did do from scratch. I was trying to learn. It was from a Blender course that I was trying to do hard surface modeling. So that one was from scratch. But then I later converted the model and brought it into ZBrush and fixed it up a bit. Just because ZBrush was a lot better than Blender. Most of these, yeah, then it came, the channel was born. You can see my lifetime. So as the pictures change, you know what I'm doing. I don't update this too often though. Not as much as my Twitter, because my Twitter feed has more updated stuff. Because it's so much easier to post on Twitter. You can post anything on Twitter. So Twitter will contain all my experimental stuff. Literally what I did 2 days ago. You'll see on Twitter. Hey, do you know if it is possible in Houdini to have access to viewport clipping? Oh, it is. It is. Yeah, that was some of the things that bugged me so badly in Houdini. Is like, why is it disappearing? Why is my stuff disappearing? So it's all about this display options. Mouse, the position of the mouse is very, very important. It's one of the things that I didn't get at the beginning of Houdini. Mouse hover over the 3D viewport. So over here, press D on the keyboard. The display options will pop up. Now that clipping, the camera clipping issue, that is, if I remember correctly, view. Yes, it's in the view tab. The view tab, clipping. Now clip, you can see it's clipping right now. I hope you can see that. Let me, okay. So if I do this, so you can see it's clipping. You get the grid, you're not going to see part of the grid. You can see it's clipping. Even though I've neither clip plane, I don't really understand this labeling. So near far planes. Nope. This one, neither. Okay, this one, the first option, and then adjust this. Okay, you can. I hope you saw that in the viewport here. So as I change this number, oh jeez. Okay, there you go. See? This is the clipping. This is the near one. This is the near plane. Hope you can see that. Keep your look onto the viewport. Okay, let's do this one here. Oh, this I need the hundreds. I guess we're not far enough for that one. Oh. 0. Okay, there you go. Okay, there you go. So that does the far clipping. Okay, I hope you get the point. Let me fix this. Okay. Okay. It's okay. I want to thank you for your answer to that question. Clipping node. Oh yeah, awesome. Thanks for staying. Thanks for staying for the hour and a half. Sorry, my streams tend to be really, really long. I'm working on that. I keep trying to talk faster, but it's not working. I mean, I'm just starting out with Houdini, or like the past 6 months is so on and off. Oh my god, sometimes I think Houdini isn't for me, and sometimes I like, oh yeah, I gotta do it. Yeah, at the beginning, it's like, I remember there was this Twitter image I saw on the Twitter feed. The learning curve is like, all the way up, and then once you get high, like there's a trophy at the top, and learning curve just all the way to cliff down. The basics are really important. What I suggest, because Houdini is very overwhelming. Houdini can do so much. I mean, I just recently discovered that it can do lip sync. Lip sync. Out of all the things that it can do, I never imagined that it could do lip sync. It can do water, it can do fire, it can do smoke, it can do particles, it can do, what else? Procedural modeling, it can do simulations, and now lip sync, CHOPS, audio files. It can do hair. Pick one topic. water, fire, particles, whatever. Pick one and focus on that one first before going into like anything else, and try to nail that down at least for a month. Give yourself a timeline, whatever. Like, don't quote me on the month. Like, it depends on everyone. So what I usually have for the members, I have this membership guide, which can be found on my homepage. This actually works for, you don't have to be a member to view this page. Just to, it's just that some of the members were saying that I have too much content and they don't know where to focus on. So I create this page for them, but it works for everyone else too. If you scroll all the way down, I have a list of thumbnails for each. I have to update this list. There's actually more categories. So if you're interested in kinefx, which is rigging and animation or clothing, just click one of these little things. It will take you to a playlist, to a list of related videos of tutorials that I have already out there. So hopefully that helps. So all these videos are linking to the free stuff, I believe. I think the member stuff are there too, but then you don't just like, the free stuff are there too. So just click on the free stuff. Like, okay, yeah, this is a member video, but this is a free one. Yeah, I don't know. It's in there. For that, I'm just starting out. Yeah. And in which language do you suggest I learn now before going into Vex, or get a general idea of all languages? That's a very good question. I would suggest I'm going to say JavaScript. But JavaScript or C. If you really want to get into Vex, if you're just going to learn a programming language just for Vex, then start off with C. But if you want to learn, because if you learn JavaScript, it will work as a double bonus. It'll help you in your career, because JavaScript is everywhere nowadays. So, and it's you get two birds with one stone. You learn JavaScript, it will help you with Vex too, just because the programming concepts are still there. The syntax is very similar, and JavaScript actually has the concept of pointers is still in JavaScript there. It's still inside the JavaScript. JavaScript is slightly simplified. So that's where the Vex is a little more complicated. But the JavaScript, I think, will work as a double bonus because it'll help you in your career as well. But if you really just want to learn a language just for Vex, then learn C or C++, because Vex was based on C and C++. So that would be the best option. But I don't know, getting a C++ job nowadays is I don't know who uses C++. Oh, rendering engine. So, but that's really advanced. You have to like learn C++ for like 10 years before you get into a job for rendering engines. JavaScript will help you right away for your career. Oh, there you go. There's my 2 cents. We got you talk so fun. Oh my god, you are so fun to talk. I'm laughing. Oh, okay. Someone looking through my window like he is mad. Well, I'm glad I'm entertaining. It took me 4 years to understand how to use the transform node in Houdini. Well, if you have any questions, I can help you now with the transform node. You need to be patient. I am sorry. I go in a long-winded. My explanations, my answers are long-winded. Laugh my ass. I DK when she will reply again. I don't know what DK is. Sorry. I was talking about Houdini, bro. Bubble is fast in replying to members and followers. Well, I try. I forgot to check the chat though. So I did forget to check the chat during the stream. I do apologize for that. I try. I need a timer on here reminding me every 10 minutes to check the chat. Cool. Does that answer everyone's questions? I'm about to close it off, but I know there's a delay in the live stream, so shoot out if you have any last minute questions, just shoot them in the chat. Don't think, just shoot it out. But even if you missed the live stream, you can always post a comment in the video. I usually reply pretty quickly for that. Oh, I don't know. Awesome, thanks. Now I know. Now I know IDK. Cool. Let me ask everyone, is anyone gonna use this dance move? I really liked it. So what I did with the dance move is one particular thing is that you can download one of the dance moves from Mixamo. But the ones from Mixamo, they don't match your music, right? So you can actually improve the Mixamo dance moves. So I've shown you how to retarget stuff using KineFX in the previous videos. So you have your retargeting over here. Actually, let me see if I can pull it up. Let me pull up the HIP file that I've done for that teaser video. That's probably the best way to show you. Is it this one? Give me 1 second. It's gonna load. I have so much loaded up. Okay, let's see. Let's go. Oh, here it is. Oh, that was in the other one. I think that was in here too, in the Steven rig. So in this rig, this is a rig that I created using Reallusion, the character creator. Because sometimes I don't have time to sculpt a character every single time. But I can't distribute the Reallusion characters, which is disappointing. The Oliver character, I keep reusing that because I can distribute that. That's something I sculpt. But anyways, that's for something else. So here I have this. So let's just ignore the chops for a second. Let's ignore this. Move that out of the way. So this is the Mixamo thing. Let me hook it all up. So this is the Mixamo animation. I have retargeted to this character. This is a simple dance move from Mixamo. Now, I took out his feet. I just deleted the feet from the Mixamo. So this is the Mixamo. Literally, I deleted the feet using a blast node. So I only have the arms. But you also need it in there. I needed something to be there though. Even though it's not there. It doesn't have to move. So I took what I blasted out, isolated it from the rest node, rest position here. So I need the feet from there. And then I merged it together. So I have a whole guy. But he's only moving on the upper part. You can see that. Put it in here. Into my retargeting of this whole thing. And then his arms are only moving. Awesome. That's exactly what I want. So then I took the CHOPS technique that I've shown you just now. And from following, so you can, hopefully this looks familiar. This is the full body IKs right here. So I have my CHOPS net powering some of the rig pose. Where is it? It's powering this one. It's powering the wrist. And the thigh. And what you get is this. He's bouncing up and down with the music. So you can augment Oh, I have to hook this over here. There we go. So this is moving with the music. It's going. You know what? Okay, so every single time you see one of the audio spectrums go up, he's bouncing. Okay. So this is without the mixamo. The mixamo ends right here. So you can see him bouncing. So this is a way to augment, so it's sort of like improve upon the mixamo dance moves. You can just using the chops to power the dance moves is a lot of work because you have to tie the bones joints to every single channel value in the channel in the chop net. But if you just take a few bones from an already existing dance move, that makes it a little easier. Oh, where was I? Oh, here. Awesome. You're welcome. Is there a Discord? I am in the process of setting it up. I want to set up a Patreon campaign, restart that, and then we'll go from there. Just because I'm working on some stuff with rendering engines. I want to make a improve the rendering engine of the flipbook or the viewport. So a custom viewport shader, I believe that's what it's called. So I'm working on that. Once that's to a certain level, I'm going to restart my Patreon campaign and it'll have a Discord server. You are doing a fantastic job. Awesome. Thank you. Thank you very much. I'm not going to use this honestly because I am not completely above subs and you are talking about chops. That is true. Chops is not the best place to start off for a beginner. That's true. I think it is a great concept. There is opportunity for R&D. Yes, that is true. It's good for proof of concept work with this chops application. Don't worry, the stream is not too long. It's just 64 minutes right now. What are your PC specs? Okay, here it is again. I get asked that question every single stream. I should just bookmark this thing. It's actually on my blog. Oh, here, the search. Ah, Squaresoft. So slow. Here you go. There's some of my specs. This is me installing my Threadripper. This is the main machine I have. And on top of that, I have two RTX 2080s. I really wish I had took pictures of how I put together my old GTX, because I had taken my GTX video card apart, completely apart, like completely took out the heatsink just because I had bought this liquid cooler bracket for it. But then later on the liquid cooler died, so I had to switch it back to the fan. And it was actually very cool how I the whole process in putting it back together, because every screw I had to, like, there's no manual, there's no thing, there's nothing. It's only, you only get the promo pictures, so I had to figure, and the screws are different. How kind of weird placement? Who designed that? The outside screws and the inside screws are all different. I wish I had pictures of that. That would have been interesting to blog. Anyway, that was totally off topic. I think I'm getting tired. PC specs, yeah. So yeah, I have a Threadripper and two RTX 2080s, right? Oh, can't remember. One question: I have zero experience in programming. Any chance for me to start with Java? Oh, I would not. Well, I personally don't like Java. That's because it's not very versatile. Java only works with stuff you need that virtual machine. I don't know if that's the case anymore, but back then Java doesn't work unless you have the virtual machine, or that their virtual, they need that special software. It doesn't work on all the architectures of PCs, which is really annoying. Like, if you throw that on a Raspberry Pi, you're gonna be screwed. Maybe, I don't know. I've never done it before. Things might have changed now. This is like, I haven't touched Java in like so long. I don't know, in a decade maybe. Java was never my thing. Java is really easy to program though. If you want to commit, because if you're learning something, you commit time to it. That's an investment in my point of view. I would, for the best bang for your buck, is probably JavaScript. That will teach you the basics of programming, and it does have references and pointers in JavaScript, so you can nail down that concept as well. If you nail those two things down, your programming becomes much easier because those are the core concepts. Thanks for showing. Do you play games at all? I don't. Who has times for games anymore? I try. I do have games. What is that game called? Anthem. That came with my graphics card. I didn't buy it. Anthem had these really amazing graphics. I only made it through the prologue. That's it. That's all I had time for. It's been sitting on the hard drive forever. I don't have time for games anymore. Zelda, Breath of the Wild. That's my favorite game. But I don't have time for that either. All I do is run around looking for kokoro seeds. That's about it. Why do you show off your website every now and then? We know it's beautiful. Oh, because most of the content from the videos I post all the content onto the website, just because the YouTube platform doesn't have any place for me to store the files. So I keep referring back to it. It's much easier to find stuff there because I've put everything on there. That's why I'm locked with Squaresoft. I can't Squarespace. I can't change host because I have too much content there. It has a lot of info. Yeah. Yeah, the blog has a lot of info. It has a lot of extra stuff. So stuff that I can't fit in the videos, I post it onto the blog. Just because some things are easier to read and it's pictures worth 1,000 words. Is it a mini wiki for Bubbles channel? Someone like that. Something like that. Just it complements the videos very well. So I just start with C, right? Or C++ Java. Give me a clear answer, please. It's totally up to you. It's still totally up to you. It depends, what are your goals, though? If you really want to learn it, I would take out Java. Python is not the greatest one to learn for Vex because Python's syntax is very different from C or NVEX. It's completely different from Z and Vex. What I'm concerned about is the core concepts of programming. Once you get that down, C and C++ will give you, by learning C and C++, you will get the core concepts of programming. And if you learn JavaScript, you'll get some of the core concepts. It has 80% of the core concepts. But C and C++ is your best suited programming language for Vex because Vex was based off of C. So go learn C, I guess, if you want a short, clear answer. Thank you for your time. I got to watch England game. Okay. Go for it. All right. I'm going to close it off. I hope that answers everyone's questions. I should have a Q&A soon. Another just casual live stream just for Q&A. I think that's probably better than everyone waiting an hour and a half for me to answer their questions. All right. Oh, thank you for coming. Thank you, Game with Juno. Thank you for joining me today for another very long stream. So the next live stream will be the next episode on the Lip Syncs miniseries. Probably, I haven't decided which topic to cover. It'll probably handle all the missing information that didn't make it through the live streams. So that's gonna come soon. yeah, this was amazing. Thank you. Thank you for watching. Thank you all for joining me today. Just I really appreciate it, and making it for the entire 2 hours, I believe it's now going to. Well, I'll see everyone in the next live stream, and I hope you enjoyed today's.